Okay, here we have yet another buffer system problem. Let's go ahead and read it. How much sodium acetate must we add to a liter of 1 molar acetic acid to give the solution a pH of 4.5? That seems like a very practical problem, right? You need a pH 4.5 buffer. You've already got an acetic acid solution. How much weak base, how much sodium acetate do you need to add? You add that powdered sodium acetate and you should get a pH of 4.5. Of course, in practice, you could just do it with a pH meter, but this will tell you exactly how much is in there. It's nice of them to give you the Ka of acetic acid, so we can go ahead and try to solve this. I want to show you briefly that the Henderson-Hasselbalch doesn't fit as cleanly for this, and so a traditional method might be preferable. If you write down the Henderson-Hasselbalch equation, you'll see that they give you everything except the A- concentration. Now you could go ahead and solve this, but since there's logs involved, the mathematics gets a little bit more complex. So a traditional method, I'm going to stop there for that one and just solve it by a traditional method. I'm not going to draw an ice table. I'm just going to go ahead and do it quickly. I know that we need the concentration of acid, and they gave you the pH. Isn't the concentration of acid within there? Yeah, it is. 10 to the negative pH is the concentration. So let's do that first and immediately realize that that's our H+. And so for our acetic acid turning into acetate and H+ equation, which I didn't bother writing, I hope that's not a problem for you, we can write immediately what the equilibrium constant expression, and you'll see that we have everything except acetate. Okay, that should put you in a comfort zone. Traditional problems, you solve for H+ and get the pH. This one we are going to solve for the concentration of acetate, and then once we have concentration in moles per liter, we know how many liters we have, 1, and we have simply to convert to grams, from moles to grams, which is pretty easy. Okay, so let's go ahead and solve for X. It's 0.057 molar. I hope you could do that algebraically. And that means 0.057 moles per liter. And if it's for acetate, that's the same as sodium acetate. After all, 1 mole of sodium acetate contains 1 mole of acetate. Don't forget, group 1's ions could dissociate completely. And so 82 grams is a mole. We get that from 23 plus 12 plus 3, etc., etc. And you punch that in, and you'll notice that, let's see. Moles cancels there. Moles over moles cancels there. Grams per liter, and it's a 1 liter solution, so we need to add 4.7 grams. So that's another example of a buffer problem.